Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello everyone. As I mentioned in my last lesson, when we did examples on circles, I said I'm going back to the topic in algebra, because we have to now look at sequences and series. So, what's a sequence? So today we are back in topic 3. Should I use black? No, I'll use blue for a change, because we are back to topic 3. Topic 3, and then I don't know what lesson number is. Lesson on sequences. Of course, there will be 3 lessons or 4 lessons on sequences. Then later on, we'll change the name. So, lesson on sequences. What is a sequence? Let me just read the scary definition of a sequence. A sequence is, if you open Wikipedia and then read the definition, or a traditional pure mathematics textbook at university level and read a definition, it says it's an enumerated collection of objects in which repetitions are allowed and order matters. Let me repeat. An enumerated collection, so a numbered collection of objects in which repetitions are allowed. Things may repeat. And the order in which you write matters. So the 4th term can't be written before the 3rd term, and so on. Remember, we talked when we did quadratic equations about the Fibonacci sequence. And when you come across a sequence every time in maths, you see, like when you every day 1, 2, 3, 4, 5, 6, 7, 8, that's a sequence. 2, 4, 6, 8, 10, 12 is a sequence. 1, 5, 10, 15, no, 0, 5, 10, 15, 20 sequence. So a sequence, in other words, can be thought of as just a set of elements following a particular rule or a pattern. So that will be the easiest definition of a sequence, even though for the sake of mathematics, I would say a sequence is, I'll write it and I'll rub it off so that you have heard it, an enumerated, mind-boggling definition, collection of objects in which repetition is allowed and order is important. Something like, you big words because you want to show off your vocabulary, or this is the correct definition based on I'm writing this from Wikipedia. It's not my definition, it is from Wikipedia, where mathematicians, great minds, have contributed to the precise definition. But for us at A level, we can say it is a set of numbers following a certain rule. Of course, the rule must be well defined. Very interesting. A well defined rule means you should be able to discern without having to worry what exactly would be the next number. That is what is a well defined rule. Let's not get into the annals of logic and abstract algebra. So, a sequence set of set of numbers following a certain rule. Very good. Now, I'll take some example. For example, you see a sequence. So let's put it there. A sequence is a set of numbers or set of objects. We only deal with numbers at A level following certain a common rule. That's it. For example, a sequence can be given. A sequence can be given in terms of its members, in terms of an ordered set of numbers. For example, Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, where after the first two numbers, every number is the sum of the two predecessors, or maybe 2 squared is 4, 8, 16, 32, blah 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 blah, or 2 over 3, 3 over 4, 4 over 5. So, no. Yeah, there should be etc. etc. n over n plus 1 for n equal to 1, 2, etc. etc. Anyway, that's one. Or a sequence can be given, can be expressed using a general term. Using a general term, generally the nth term or nth term. Normally, by notation, we use u1 as the first term, u2 as the second term, u3 as the third term. So, for example, un equal to 2 power n minus 1. N belongs to n. So, in other words, u1 will be 2 minus 1, which is 1. u2 will be 4 minus 1, which is 3. u3 will be 8 minus 1, which will be 7. u4 will be 16 minus 1, which is 15, and so on and so on. So, you can give it in terms of the nth term, but not necessarily. Sometimes a sequence is given in terms of a recurrence relation. That means a recurrence relation is a relation connecting some terms. Like, for example, a sequence can be given in terms of a recurrence relation. For example, you have been given u1 is equal to 1 and un plus 1 equal to 2un minus 4, 2un minus 3, and un equal to, let's say, 1. So, put n equal to 1, I get u2 equal to 2u1 minus 3, which is 2 minus 3, which is minus 1. That means you generate each term by using the previous term. Put n equal to 2, u3 will be 2u2 minus 3, which is 2 times minus 1 minus 3, which is minus 5. u4 equal to 2u3 minus 3, 2 times minus 5 minus 3, which is minus 13, and so on. So a sequence can be defined by can be represented by a certain number of terms, or it can be defined using a general term, or it can be defined using a recurrence relation. The only thing you should know is if a recurrence relation is given, how to use it to generate the terms. Sometimes, generally at AS level or even at A level, they will give the recurrence relation. For example, I'll just take an example of recurrence relation only because nth term we will come across again a lot of times later. So, for example, a sequence is given by un plus 1 equal to 5un minus 6un minus 1, u naught equal to 2 and u1 equal to 3. Something like that. Find the first 6 terms of the sequence. So put n equal to 1, because remember, I know u naught. What happens when you put n as 1? I get u2 equal to 5u1 minus 6 u naught. So let's put u1 as 1. So 5 times 1 minus 6 times 2 is minus 7. Put n equal to 2. u3 equal to 5u2 minus 6u1. So that is 5 times minus 7 minus 6 times 1. So minus 35 minus 6 is minus 41, and so on and so on and so on. You can find the others. Sometimes, what happens is there are, I can't straight away make up examples, but if you look into various old AS level textbooks, you will see something like the sequence will have minus 2, 0, 1, minus 2, 0, 1, minus 2, 0, 1. It keeps on going round and round. Such a sequence is called an oscillatory sequence. Sometimes the values keep on reducing, like, you start with 10, 8, 4, 2, maybe half, 1/3, 1/5, 1/9. As you go further, the values become smaller and smaller. Then the sequence is convergent, or sometimes the values keep on increasing, either in the positive or in the negative direction. So sequence can be convergent, can be divergent, can be oscillatory. That's not in the purview of A-level syllabus, so I'm not going to deal with it. But I'm going further to look at 2 particular types of sequences. In India, of course, we would do 3, the harmonic as well. But for you people from UK and elsewhere, we're looking at only the arithmetic and the geometric sequences, which I'll take up next time. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.